us rode the bike. So if you're going this direction and there is a tailwind, you have a combined speed. For a tailwind. So whatever you have plus the wind, that will be your actual speed. But if it's the opposite situation, so this is you on a bike and this is the wind, still a combined speed, but this time it's x minus y. And we hope that y is not bigger than x because they're not going to get anywhere. So the same thing happens here. When we talk about the speed and velocity, I'm sorry, acceleration I want to write. When we talk about the two forces that we are that in the problem, the speed and the acceleration, if they go in the same direction, if the speed and acceleration go in the same direction, the particle is speeding up. But if the speed and the acceleration go against each other, the particle is slowing down. So what I need to do is study the sign of both and see what happens. So this is the velocity. This is the acceleration. And here's conclusion. Of course, we are looking at 0 to 8. We already know, because we studied the sign of the velocity already, that we have at 2 and 6, the velocity is 0. I'm just copying it from here. It's positive, it's negative, and it's positive. That's done. But now I have to study the acceleration. The acceleration is 6t minus 24. So 6t minus 24 equals 0 will mean that t equals 3. T equals 4, right? T equals 4 seconds. 24 divided by 6. So right here, between 2 and 6, there is 4, and the acceleration is 0. The leading coefficient is positive, so the acceleration looks like this, from negative to positive. And now I'm ready to draw conclusions. So what would you say the particle is doing between 0 and 2, knowing that the velocity is going this way, but the acceleration is going this way? What will the particle do? Speed up or slow down?
Slow down.
Slowing down. Next, between 2 and 4, both forces are negative, meaning they are going this way, but they're going together. So in the same direction, they are not working against each other. So what does the particle do between 2 and 4?
Speed up.
Speeding up in this direction, but that's not important. What we want to know is when is it slowing down, when is it speeding up. So speeding up. Speeding up. Okay. Now, between 4 and 6, what is the particle doing between 4 and 6?
Slowing down.
Yes. Finally, between 6 and 8.
Speeding up.
Thank you. That's it. Same idea with airplane and the headwind and airplane and the tailwind. Same idea. The other forces work together to speed up, or they work against each other to slow down. Any questions, please? Any questions? looking at a different problem now. This caught my eye, problem 26 here. So let's see what it's asking us to do. The number of yeast cells in a lab culture increases rapidly initially, but levels off eventually. The population is modeled by the function. So let's copy the function first. So n equals f of t, which is a divided by 1 plus b e raised to negative 0.7 t. I'm checking without glasses. Yes, I'm correct. Make sure that I copied it correctly now. T is measured in hours. I have to take those notes. At time t equals 0, the population is 20 cells. When I'm told that at time t equals 0 hours, population equals 20, what does this represent immediately?
I have a question.
Please.
As the on E for the exponent, does that say negative 0.7?
Yes.
Okay.
Yes.
Just wanted to clarify.
I looked carefully, make sure that I didn't copy it incorrectly. Yep. I hope you
Sorry,
can.
it was just a little bit blurry. You're good.
I looked twice after I copied that squared where it wasn't supposed to be. I even took I don't read with glasses, but they are sometimes are kind of strong and it can get blurry. Okay, so what does this tell us? That time, if I tell you when time is 0, population is 20 cells, what does this really mean immediately? So we have this in the back of our minds. What does it mean?
It started with 20 cells.
We are given a point, 0, 20. When t is 0, f of 0 is 20. Perfect. It is increasing at a rate of 12 cells per hour. At that moment, it says, one more time, at time t equals 0, population is 20 and is increasing at a rate of 12 cells per hour. What does this represent right here? What should I write? And we are asked to find A and B. But I have to identify what this means before I move on. What do you think it means? Should I read it again?
Yeah, one more time, please.
Very good, sure. So, at time t equals 0, the population is 20 cells, and the population is increasing at a rate of 12 cells per hour. Find the values of A and B.
Would it be your rate of change?
Good. So how do I write it? Yes, great job. But how do I write that? So I know exactly what it is. When we talk about the rate of change, what do we have in mind? Always.
The first derivative.
Thank you very much. F prime of 0. At the same instant when the population is 20, at that instant the rate of change is increasing. So that's why I put positive. I didn't write it, but it's positive because it says it's increasing at the rate of 12 cells per hour. Excellent. Good. So now we're asked to find this and this. How many unknowns we have and how many equations we need?
You have 2 unknowns, that means we would need 2 equations.
Great job. So can anyone give us the first equation?
A equals 1 plus B to the 0.7t.
How do we, so what, did you,
We'll set f of t equal to 0, multiply...
but why will I set it equal to 0?
Never mind, doesn't work.
No, I don't have, I can set it equal to 0. So
Well,
the,
my thought was if I set it equal to 0, then I can multiply both sides by 1 plus b e...
but I have to have a reason to set it equal to 0. I have no reason to set it equal to 0. I don't have any information that tells me that, that the rate of change is 0.
Do you plug in the point?
I have to. That's why I put this in here first. So when t is 0, f of t is 20. This is crucial to understand. So when this is 0, so I have a over 1 plus b e to 0 times negative 0.7, I'm going to write it as 0, must equal 20. This comes from the point. When t is 0, f of 0 is 20. And I know that e to 0 is 1, so then our first equation is a over 1 plus b equals 20. Later we'll write it. What about the second equation? So I already have a first equation. I have one equation that has a and b in it, but I need one more. So obviously this is done. Now what else I could use? Because I'm given one more piece of information, and I have to use it.
Use f prime of 0 equals 12.
That's it. F prime of 0 equals 12. So now, before we rewrite the system, let's find f prime. Because if I can't plug in 0 in something I don't have. I have to have the function. So let's find f prime of 0. F prime of t and then f prime of 0. Like I said before, this function is a ratio, but the numerator is a constant. No one will ever force me to use the quotient rule. Go ahead if you want to. I will never do that. 1 plus b e to negative 0.7t raised to negative 1. So then I differentiate this, because I put already the prime in there. So I bring negative 1 in front. I subtract 1 from the power. And now I have to differentiate the inside. The inner function prime. This prime is 1. 1 prime is 0. Gone. So then plus b, which is a constant. Done. And now I have to differentiate this, which is e to negative 0.7t multiplied by the inner function prime. In parentheses, so one more time, I replaced 1 over by the expression to negative 1. And now I'm ready to differentiate. I bring down negative 1, I multiply by a. I subtract 1 from the power. And now I differentiate the inner function. 1 prime is 0, b stays b because it's a constant, times this function prime, which is e to u, e to a function, times the inner function prime, which is negative 0.7. Now I have to rearrange a little bit. So let's see what we get. So f prime of t. First of all, I see two negatives. So it's 0.7a, 0.7a, this and this, and also b. So negative a times b times negative 0.7 will make 0.7ab. This has a negative exponent, this has a negative exponent, they will go to the denominator. B to, sorry, I meant to write e. E to 0.7t, I'll erase it in a minute. And in parentheses, 1 plus b e to negative 0.7t, everything squared. Okay. Now I will replace t for to create the second equation. I will replace t by 0. Well, let's see what we get, and let's create the system. First equation, e to 0 is 1. First equation is a over 1 plus b equals 20. And now the second equation is f prime of 0 equals 12. So when I replace t by 0, this is 1. When I replace t by 0, this is 1. So what we have is 0.7 ab divided by 1 plus b squared. So again, with 0, 0.7 times 0 is 0, e to 0 is 1, e to 0 is 1, I still have 1 plus b and I have squared. Okay, now we have to make a decision. We cannot use elimination. We have to use substitution somehow. Let's see how we do that. We can from here cross multiply, and we get that a equals 20 times b plus 1, or times 1 plus b, doesn't matter. So a equals 20 multiplied by 1 plus b. We are going to replace a in the second equation by 20 in parentheses 1 plus b. This part of algebra is less important, but what was very important is to identify what the problem was telling us. Okay, so I have 0.7. I replace a by 20. In parentheses 1 plus b. I still have a b. And the denominator is 1 plus b, everything squared. And this equals 12. Of course, I will eliminate one of these. And now I will cross multiply. 0.7 times 2 will be 14, right? Because this is 1.4 and a 0, so 14. And then b equals 12 and parentheses 1 plus b. So then 14b equals 12 plus 12b. I subtract 12b, so I get 2b equals 12, so b equals 6. With b equals 6, I go back to determine a. So 6 plus 27, so a is 140. So 7 times 20 is 140. So then we have our function, which was a 140 divided by 1 plus b was 6, e to negative 0.7 t. Any questions on this problem, please?